Six Sigma Simplified, eliminating defects like a pro. It is impossible to write a book on lean without touching on Six Sigma. After all, we now call it Lean Six Sigma. I promise to keep this chapter as qualitative and easy to read as possible using a cucumber cutting example. What is Six Sigma? Sigma is a letter in the Greek alphabet sigma. In 1986, Motorola invented methods to measure variation within a system. Some used the mathematical formula for standard deviation, symbolized by sigma. How is it used? Okay, let's cut some cucumbers. If you try to cut 1 centimeter cucumber slices, the slices will be slightly larger or smaller than 1 centimeter, no matter how accurate your knife. No big deal, it is just cucumbers. What is a little bit of variation in size, right? But what if instead you were cutting diamonds for laser surgery machines? Six Sigma methods test our variation by measuring how spread out our cucumber sizes are. This is called distribution of data points. Testing that over 99.99% are around 1 centimeter long, and therefore deemed defect-free. Below is a simplified chart. We have cut 11 slices of cucumber and plotted their sizes. Let's also assume that we already ran all the Six Sigma calculations, and we know that we can accept all slices that are between 0.7 centimeters and 1.3 centimeters. As you can see, no two slices were the same size, though some were very similar, like A and I, or D and F. We have two types of variations. Slices C and H are outside our range. They are called special cause variation. The other slices also have variations, but this is a natural part of any process. They are called common cause variation or intrinsic noise. But where does the name Six Sigma come from? Sigma, or sigma, comes from the statistical standard deviation formula. It is a term that means quality. A project that has 6 sigma level has less than 3.4 defects per million. Let's conclude with looking at the formula of sigma. It is the formula for standard deviation. When we say something deviates, we mean it strays from where we think it should go, like a ship that moves away from its planned course. Let's assume our average cucumber slice is 1.0 centimeters thick. We want to know how much our entire cutting deviated from this average. How much mistake in cutting are we making? We have 11 slices of cucumber. Each slice has a different thickness: 0.8 centimeters, 1.0 centimeters, 0.5 centimeters, etc. These are called data points. Data points are xi. For simplicity, let's assume our average slice is 1.0 centimeters thick. Average is all the slices divided by the total. 0.8 plus 1.0 plus 0.5, etc. divided by 11. Average is mu. How much thicker or thinner are our slices from 1.0 centimeters? To avoid any negative numbers, we will square that. 0.8 minus 1.0 squared, 1.0 minus 1.0 squared, 0.5 minus 1.0 squared, etc. This is xi minus mu squared. We want the whole deviation, so we will need to first sum it up. 0.8 minus 1.0 squared plus 1.0 minus 1.0 squared plus 0.5 minus 1.0 squared, etc. Sum is sigma, and then divide by 11 to average it out. 11 is our population size. Population size is n. Finally, we must use the root function, since we did a square before. Our result is our standard deviation. Let's assume it is 0.1 centimeter. This means our cucumbers are on average 0.1 centimeter larger or smaller than 1 centimeter. This is also called sigma.